So today we're going to solve this simple question on alternating current. The question is on the board, as you can see. It's a series circuit, and in this question we've been given the resistor having resistance 80 ohms. We have the inductor having inductance 700 millihenry, and we have the capacitor having capacitance 25 microfarad. The AC source voltage is 220 volts and the frequency is 50 hertz. Normally when you are given a voltage like this, it is always assumed, except stated otherwise, that the voltage is actually the root mean square voltage. That's the RMS voltage. So the questions calculate the impedance of this circuit, the root mean square current, the peak current, and then the resonant frequency. Now before you can solve for the impedance, you have to first know the reactances that are also involved in that circuit. For instance, immediately you have an inductance, or you have an inductor having inductance, you should note that there's going to be a reactance. Reactances are actually the opposition to changes in alternating currents by either the inductor or the capacitor. So here now, when we want to find the impedance, the question for impedance, which in earlier classes we've already established that impedance is Z, and impedance is actually the overall opposition offered by these three components to the flow of an alternating current. The components are the resistor, the inductor, and the capacitor. So the combined opposition by these three components in the circuit will now give rise to impedance. So what's the question for impedance? We know that our impedance is given mathematically as the square root of R squared plus XL minus XC, then bracket R squared, where XL we understand to be the inductive reactance, okay, and this is XC. XC is the capacitive reactance. From our earlier class, we've established that XL, which is the inductive reactance, is given mathematically as 2 pi FL. So we can get the value for this. We know that pi is constant, 3.142. The frequency has been given as 50 Hz. The inductance has been given as what? 700 millihenry. Now millihenry there means our L, which is 700 millihenry, will now be established or can be converted as 700 times 10 raised to power. Milli means what? Minus 3, then what? Henry. It's like saying 700 divided by 1000. That should give about what? 0.7. Can also write this as what? Can write it as 700 divided by 1000 is what? That should be 0.7 Henry. So let's get the inductive reactance. So our XL will be given as 2 times, what is pi? 3.142. Our frequency is what? 50. Then multiplying the inductance, which is now what? 0.7. Please, can someone give me the multiply this and let me have the answer?
219.94.
Someone should confirm that. 219.94 ohms. Inductance is also in ohms. So that's our inductance. Inductance is in ohms, whereas inductor itself, capacitive inductive reactance rather is in ohms, whereas inductance itself is in what? Henry. Okay? So we've established and we found our inductive reactance. Let's go for capacitive reactance. So our XC, capacitive reactance, the equation is 1/2 pi FC. Some students used to confuse themselves between XL and XC. Anytime you see XC, it's always 1 over. And what is even this inductive and capacitive reactance? This one is the resistance to changes in what? In voltage by the capacitor. This one is resistance to changes in current. For inductive. For inductive reactance, it's always for changes in current. But for capacitive reactance, is opposition to what? Changes in voltage, mostly. So, now, we solve it as XC equals 1 over 2 times, what is pi? 3.142. What is F? 50. Then multiplying capacitance is 25 microfarad. Now we know that 25 microfarad is the same thing as 25 micro means 10 raised power minus 6. Is that okay? 10 raised power minus 6. You can write this as 25 times 10 raised power minus 6 farad. So you now come here and put 25 times 10 raised power minus 6. Now from there, we can say that our XC will be given. You can get this directly in your calculator. If you put this in parentheses, you can just say 1 divided by all this and you will get your answer. But probably from indices, you can take these 10 raised power minus 6 and drop it up and it turns to what? 10 raised power 6. And 10 raised power 6 will multiply 1 and you still have 10 raised power positive 6. And that will be divided by 2 times 3.142, then times what? 50 times what? Times 25. 50 times 25. Okay? 10 raised power 6 is about 1 million. Then you multiply everything in the denominator here. Please get the answer from me. Let's see what we have for our XC. 127.331 ohms. Okay, so we've gotten our capacitive reactance. We've gotten our inductive reactance. So to find the impedance now, knowing that R is 80, we now put all these values into our equation. So let's see for impedance. Our impedance now, Z, will now be given as the square root. Let's see, square root of, what's our R? Our R is 80. So that will be 80 squared plus, you open bracket, our XL. XL, we found it to be what? 219.94 minus XC. Our XC has just been found to be what? 127.31. Then you close the bracket and you square it. So it means that our impedance will be given as the square root of, please square 80, what do you have? 6400 plus 219.94 minus 127.31. Then you now square it. Everything that will give you what? 8. Okay, let's say 0.32. Okay, so add the two of them, you're going to have our impedance to be the square root of, add the two of them, what do you have? $1,498. No, 1,498.0.32. So if you take the square root of 1,498.32, what will you have? 122.39 ohms. First problem solved. That is the impedance offered by those three components to the flow of the alternating current in that circuit. So the impedance, which is the combined opposition by the resistor, the inductor, and the capacitor is 122.39. So this has been solved. So let's go for the next one. The next one was to find what? The root mean square current. Root mean square current. We need to find the root mean square current. Now, the normal Ohm's law that we know for direct current is that V equals to IR. As voltage is current times resistance. This is for a direct current circuit. But when you are playing with an alternating current circuit, the equations are very similar, just that our resistance will now be called what? Impedance. So the equation will now be V equals to what? IZ. Now I've told you that when voltages are given, except stated otherwise, because they could have to tell you that this voltage is maximum voltage. The way it is not stated, then you note that this voltage is going to be what? The root mean square voltage. So it means that our VRMS will also be given as what? IRMS then times what? Times Z, which is the impedance. So what we are asked to find in the second question is what? The root mean square current. So quickly, we now have IRMS to be given as, making the subject the formula, VRMS all over what? The impedance. So what's VRMS? 220, so that would be 220, then divided by our impedance is what? 122.39. Can we have the root mean square current? 1.79 amperes. That is the second part of the question. Now the third part of the question is to find the peak current. Peak current at any point in time, you have to find the peak current. We know that VRMS is always given as what? 0.7071 V naught. Is that okay? If VRMS is given as 0.7071 V naught, you can make V naught the subject of the formula. If you make V naught the subject of the formula, it means that our V naught will be given as what? VRMS all divided by 0.7071, which in this case is going to be given as our VRMS is what? 220. Is that okay? 220 then divided by 0.7071. Please, what's the peak voltage? Quickly. Yeah, it has to be more than 220. So that will be 311.13 volts. Immediately you have gotten your V naught, then to find I naught becomes easier. Still using the equation. So we can now find I naught equals I naught times what? Z. And we know V naught now to be what? 311. So you can find I naught. So you can say that I naught will be given as what? V naught all over Z. So our I naught will now be given as, what is V naught? V naught is 311.13 divided by impedance, which we had earlier solved to be what? 122. Was it 122? Yes. 122.39. Please, what is our peak voltage? 2.54 amperes. That's one way of solving for the peak current. There's another way you can also solve involving the resistance 80 ohms. But I use this other method and you will still have the same answer. So the last one is to find the resonant frequency. So you copy this. Resonant frequency, we've established that for resonance to occur at any point in time, the inductive reactance must equal the capacitive reactance. That's the condition for resonance. That's to say, for we to have resonance, XL must equal XC. That's the condition for resonance. And we know that XL is 2 pi FL. Whereas XC is what? 1 over 2 pi F what? C. Now, you can solve for the equation of decimal frequency. At this point, when this equals to this frequency will now be called F naught. So if you cross multiply, we are going to have 2 pi, at resonance this F turns to F naught, then L, multiplying this other 2 pi F naught, then C, and everything equals to 1. Is that okay? So you now open the bracket. 2 times 2 will give you 4. Pi times pi is what? Pi squared. F naught times F naught squared. L times C, LC. Everything equals 1. So from there, you make F naught squared the subject. What's making F naught squared not to stand alone? 4 pi squared LC. So you can now say that F naught squared equals 1 divided by 4 pi squared. Then what? LC. 4 pi squared LC. We are looking for F naught, not F naught squared. So if you want to find F naught, we now take the square root of both sides. The square root of both sides, that will be the square root of 1 divided by 4 pi squared LC. So it means that our F naught will be given as the square root of 1 is what? 1. The square root of 4 is what? 2. The square root of pi is what? Pi squared is pi. The square root of LC remains square root of LC. So this is the equation for our resonant frequency. And now substitute the value. The value for our L is 700 millihenry. The value for our C is 25 microfarad. So we can now solve for F naught. It will be given as 1 divided by 2 times 3.142 times. You now have the square root of what is L? L is 0.7. We established that 700 millihenry means 700 divided by 1000, which is 0.7. Then multiplying C is 25 times 10 raised to the power minus 3. If I also want to write it in terms of decimal, I can say 25 divided by, okay, this is micro. This is micro, so that would be too much for decimal, so we'll do it in standard form. So you can use your calculator directly and get your F naught. At any point in time, our resonant frequency, after plugging this into our calculator, we have 38.04 Hz. It's also in Hz. Alright, so that question has been solved. Feel free to go through it again. And when next we return, we solve another problem, but this time around in parallel. We are going to be solving a similar problem, but when these main are going to be arranged in parallel. And that's where we are going to be having our admittance, subsistence, and then conductance.